All right. So the topic is detecting price manipulation attacks. We'll be getting over to that. Just a quick intro about me. My name is Tejaswa Rastogi. I'm a security auditor at Consensus. I'll be presenting a talk over detecting price manipulation attacks. And talking about some of my areas of interest and research. Well, right now, mostly indulged into cryptography and maths. So if you like to get in touch with me, always feel free to join. And there's Twitter handle, raise a tweet. You can just ping me anytime you want. All right. So let's get started. So what I will try to do, we'll keep things very beginner friendly, and I'll try to explain things on a very layman's term so that everyone can catch up what's going on here and what's the problem and what we are trying to solve and what's the requirement here. All right. So the first thing first, why existing tools are not enough, right? So, well, the problem is that getting price feeds that too correctly is a logical implementation, right? And may not be detected as a sort of static analysis, right? So it's not kind of possible in a static analysis. So we need something more than what we can perform besides static analysis, right? So if we take into account tools like Slither, right? So this Slither like tools, we can detect issues in our code, right? Code vulnerabilities, reinforcements, and all this stuff. But talking about these price manipulation attacks, they are much more than just a code flow, right? So they are kind of logical vectors and exist logically, right? And they kind of depends upon the network itself. All those mempool and stuff, I'll talk about that. All right. So, like, what do we want? Obviously, we want these type of attacks to be detected and like not just be detected, but prevented, right? And possibly stopped. So we need to find a solution, right? So the first thing that might stroll down your mind is we can detect these patterns, right? The patterns where somebody just interacting with a protocol to doing all sort of crazy stuff. So maybe we can detect these, detect these patterns from the transaction, right? Exactly, right? That's what we want. And that's what we will try to research, possibly, or giving you some ground so that you can continue this research and make some more tools, implementation on that. All right. Okay, so let's talk about the spot price, right? Now we have a ground, right? We have a base to start with that we need to analyze the pattern and possibly do something over that. But let's talk about the main villain here. So the villain is kind of the spot price. So let's just try to understand what the hell is spot price in general, right? A layman's term. So, well, AMMs kind of create a spot price based on the reserve ratio at a point of time. So for instance, let's take an example. If we have a pool of ETH and USDC, right? Let's say we have 2 ETH and 100 USDC. So the spot price of ETH in terms of USDC will be simply Y by X, right? Or the balance of USDC divided by the balance of ETH, right? So it will be simply 100 by 2, that will be 50 USDC. So per ETH is 50 USDC, or we can say 1 ETH in USDC terms costs like 50 USDC, correct? Sounds about right, right? And all right, let me switch to my camera, I guess, if it's possible. Hey, everyone, I can see me. All right. So what I was talking about, the spot price, yes. So the spot price is the main villain here. Why so? Because in most of the DeFi protocols, what they do or how this fetching of the fees, the price fees are implemented is directly fetching the price from the pools or from the fees. And how they are calculated is simply a ratio of Y by X. correct? So, and what if I want to swap my token? Then we have a simple equation. Take an example of constant product AMMs. So the curve is like x multiplied by y equals to k. So that's how the graph looks like. So let's assume we have x and y tokens because we have to give them an equal amount at the time of or some amount at the time of creating pool. So let's say there's 10 and 10 tokens of x and y. We added some value, right? We added some value of x tokens, or let's say we are doing a trade of x tokens in return of y tokens, right? So the x will be increased to dx, right? And the y tokens will be removed, will be reduced to dy, right? So the intersection point is where the new, I would say, the liquidity pool will be, or the reserve ratio will be. And the amount like y minus dy is the output amount that you will be getting, right? Like we know about this. And this is the equation that looks like an Uniswap, considering the 0.3% of fee price, tax price, or whatever it is, right? So that's how it looks like, and that's how the spot price works. And that's the main goal, right? Because most of the protocols, we are fetching the spot price value, and we know that is supposed to be changed, right? Frequently, more frequently, because if we are relying on the latest answer, right? Latest price, obviously we'll be getting into trouble. We'll come on to that. All right. So let's see what does a typical price manipulation looks like. Well, follow a hack that happened on June 16th, 2022. Inverse Finance cost about like $1 million of loss. So what happened? Let's see this in action, right? So what attacker did, it first took a flash loan, right, of wrap BTC, something around 27,000. This is the contract address which you are seeing in the receiver address. So it took a flash loan worth 27,000 wrap BTC, and then some part of it, like 225 wrap BTC, is used to convert, or you can say add liquidity. And then we got some Curve3 crypto tokens. We used Curve3 crypto tokens, or attacker used Curve3 crypto tokens after that to deposit into the pool YB Curve3 crypto, and got some got some tokens, 3 Curve. I guess I can see the screen. Yeah. Sorry. All right. Sorry. It's UNC tokens, right? So it got some UNC tokens in return. All right. What else? After that, yeah, here we go. It fetched the price. So it was something like this value. And what it did, like, as we know, so the UNC tokens that we got from the last slide, right, that will be used as collateral in the inverse finance. But what we'll be doing now, okay, the attacker first fetched the price, like what is the current price from the feed, then it exchanged the remaining, right? Remember, we had 27,000 wrap BTC. We got some collateral from a part of it, and the remaining is used to exchange the wrap BTC to USDT, right? The Tether token. So we exchange this, like why we are doing it, in order to uplift the price, right? That's how price manipulation works, like, right? So we have uplifted the price of USDC because we are extracting USDC from the pool, right? Obviously, it will be more expensive now to buy. Now, obviously, it will be more worthy, right? And again, if the attacker fetched the latest price, now it's much more than the previous one, right? So what happened here is we have artificially inflated, right? We have artificially inflated the price of our collateral. So what if we deposit that collateral to try to borrow some tokens, right? As we have already inflated the price, now our collateral worth more than the amount, like in general, right, as the intended value. So that's what attacker did. It borrowed the dollar tokens at a much higher worth of its collateral, right? And then again, simply what we do, exchange the USDT back to REP BTC as like a reverse trade to resume the price down of the price oracle of the spot price. Then exchange. Okay, so ignore the third image. I guess I've pasted this twice. So after doing a reverse trade, the attacker regain the curve tokens, 3 curve tokens, remove the liquidity, got some USDT back in the 4th image here, the token, and that will be used simply to repay the flash loan and interest rate. And now you can observe that as we have resumed the price, right? Now our collateral is like under collateral, right? Because the price of our collateral is way less than the amount we have borrowed, right? So we don't care about it being liquidated. Like let's just go because we have already borrowed much more than what we want, right? If you want to see the whole source of the transaction, you can just visit the DEX one and can just see the whole history, right? Okay, let's just move on. So we have now seen how price manipulation looks like in general, like what a typical one looks like. So what do we want, right? We want to analyze this pattern, right? So that we can obviously do something about it, right? So as we have already seen that this is not possible at the code level, we need something extra, right? So what we can do, we can analyze the transactions, right? The raw transactions, and can extract something out of it. So the first thing of pattern analysis would be is limiting the scope of analysis, right? So if you visit the transaction source, the extracted trace of the transaction listed in the previous slide, you will find there are a bunch of transactions going on, bunch of internal transactions going on, right? But like, do all these internal transactions matter to us? No, right? Because we just need the things that will help us in analysis, right? The first would be the flash on itself, right? We can trigger analysis whenever we find a transaction, a flash loan, right? And can start an analysis, probably start about two, do some monitoring, detection, and yeah, the further steps. Now, moving on to like internet transactions, right? For people like who just misguided by this term internal transaction, let me just clarify it for you. Well, there's no such concept of internal transactions, right? Why so? Because let's just talk about what are internal transactions basically. So internal transactions are those when let's say a smart contract is interacting with another smart contract, like doing a function call or sending ethers, right, to another contract, or to an end user, to an EOA back, right? So those are all internal transactions. And let me just ask you, can smart contract initiate transactions, right? You would say no. The reason is smart contracts don't have private keys. They cannot initiate transactions. They cannot do anything by their own, right? They're supposed to be called by an end user, right, to get things started. So if smart contracts don't have private key, they cannot initiate internal transactions, right? So we don't have cryptographic signature or proof of this transaction, right? If we don't have a cryptographic proof, that means this is exactly not a transaction, right? Yes, this is not a transaction. This is a step, you can say, a call depth that is going on based on the data that we provide in the top level call, right? And now you will say how these block explorers, right, give us a flexibility to just go onto the transaction, and it gives us a tab of internal transaction. Well, these block explorers do the same thing. They run a modified node to take into account the call depth that is going on from the top level transaction, extract the opcodes that are being traced, and give us a flexibility to consider these further steps as some sort of internal transaction. So don't be confused with this term internal transaction. This is just a terminology launched by us for easier understanding, right? That's just there. So that's how internal transactions work. Now we have to get these internal transactions, right? Because that's what matters to us the most. Because from the external transaction, what we can get is just value of like from to like maybe the data, right? Of the function being called of the first top level smart contract, right? Let's say I am an attacker, right? I've created a smart contract, and inside the smart contract, I'm taking a flash. So the top level external transaction will give me access to this data, the metadata of like from, to, and what I've like triggered, maybe a function call like function XYZ of my smart contract. How that would be helpful to me, right? That won't be helpful in any of my analysis, right? I want something more, right? I want the complete execution of that trace, right? I want each and every step that is going to be executed in that transaction, so that I can possibly go ahead and try to do something with it, right? Yes, that's what we want. Moving on to, yes, let's say we now have execution trace. We get into it, like we can get some possible approach of how we can get the trace of it. But let's say we got a execution trace of it. But as we have seen in the previous slide, like all of these internal transactions don't matter to us. We want some specific part of it, right, to help in my investigation or analysis. So what I will do, I will rectify these steps and filter them down to only those steps which are highly required, right? So the first step may be the flash zone itself, the transaction of flash zone. Second would be token transfers, right? Because for every swap, they'll be doing like for the flash zone, there will be a token transfer. We'll be inflating the price, right? We'll be trading tokens. That will be again a swap, right? That will be again a token transfer. So we'll be taking those into accounts. Then the token trades, right? Uplifting the price, as we just discussed, swaps and all. Then there might be a transaction interacting with a DeFi protocol. We'll mark that as well. And then there will be a reverse trade. So we'll mark that as well. So these are some of the actions that we can get into our bucket list that we want to analyze, right? So that will simplify some of our steps in our analysis, right? Okay, moving on. Let's say we got the actions as well. Now let's just talk about how we can actually get these traces, right? What are the possible approaches? So two things that I was researching, let me just present it to you. These two methods that are like widely famous and can be utilized for that. There might be other approach that you might suggest would be much more flexible. Let's take into account as well. So debug trace transaction, debug trace call. These are very cool methods, right? So these methods are available in the get node with the debug, obviously debug mode on, features of debug and trace APIs. So what they do, the debug trace transaction, let's talk about the debug trace transaction. So it gives us in account the outputs, right, that are going to be executed in a trace or in execution, right? So it will help us run a transaction that had already been executed and trace it down the complete steps. But like you might ask, like how it could help us, right? What's the point of tracing a transaction that has already been executed, right? What's the point of tracing a transaction of an attack, right? Of a price manipulation attack that has already happened, right? Like if I build something like that, then I guess it would be the most dumbest tool of the year. And like people would say, it's like saying, like the tool is saying, hey, the hack that just happened recently, which caused us $30 million of loss. I confirm that that is a hack, right? So that is like saying the most dumbest thing we have made. We need to trace this transaction before its execution, right? That's what makes sense. So what we can do, what is supposed to be done, is to trace the execution of a transaction in its pending state, right? In the pending block itself. So that's where debug trace call could help us in that, because what it does, it does basically the same thing to help us run a transaction, yeah, but it does that with the final state of the parent block, right? So now it will ring a bell, right? That yes, that's kind of something we want, correct? Right? That's kind of something we want. So debug trace call is something we can move forward with and continue our research, right? Like as I say it again, there might be a couple more things that we can utilize and much more efficient, right? This is what I was researching, so I've just added that. Moving on to, let's say we got our internal transaction. We know what we want to analyze, right? We got all the traces. We have systematically made a kind of execution trace. Now what next, right? What we are supposed to do with it? A very nice approach is mentioned by like these researchers in their paper DeFi Ranger. I will highly recommend going through it and reading about it. So the next step could be to build a cash flow tree, right? Cash flow tree, like what is supposed to be done in the cash flow tree is you got all the internal transactions, right? Now you're supposed to make a pattern out of it, right? Let's say a flash loan. Adding to it, we want to attach it the transfer event that happened. Remember, we talked about some actions, right? The swaps going on, yeah, the token minting, reverse trades. So all those transfer trades, because transfer is what matters the most to us, right? So what we'll do, we'll attach these transfer into the parent node, and we'll try to create a graph out of it, right? A tree out of it, and avoiding all the like irrelevant part. So in the like at the end, what we will get a pattern that we can match with our predefined, right, existing patterns, the suspicious patterns, right, that we have already predefined. Like if it goes like that, then you should be considering it suspicious. We'll match it against those. And if the score, like the higher the score, the more suspicious that transaction, I can mark it down, right? So remember, we are marking a suspicious score as well to these internal steps. So if we see that, okay, the flash loan is going on, now the attacker has done swaps with a huge amount, uplifted the price, interacted with the protocol, deposited collateral, did a reverse trade. So all these steps is kind of making a suspicious pattern to us that we can match it up against and can say, okay, we found a suspicious pattern, and then we can move ahead with the next step, right? So what else in the suspicious marking, suspicious list, right? Remember, there's a very unique pattern that has been found in like most of the hacks that we have seen is using coin mixers, right? Like Tornado Cash. So what attackers usually do, they use coin mixers like Tornado Cash to fund the initial ETH right? To start their process, to start the transactions and all. And then at the end, when they try to like when they get the funds they want, the attack is completed successfully, they again they again go to coin mixers to like zero knowledge proofs and all the stuff, and take out the funds from another account as you can say flushed privacy history one, right? Those kind of stuff. So this is a very widely known pattern, and we can also mark this as a suspicious list, in a suspicious list, right? So now we have discussed what we want to do, how we want to do, and the suspicious pattern list that we want to generate. And we also discussed like how we want to generate these traces, like some methods. Parity also provides some methods as well, but that is kind of expensive in a sense. They're kind of complicated and takes much more, I would say, time and not very efficient. So kind of expensive to use. So Geth is an easy one to just run through. So that is one we can use. Now we can head over to the challenges, right? That are still there, because this is an approach. This is a current area of research, we can say. We want to build. There are some existing tools, and there would say kudos to the front running tool from Blocksec. They did a great one. And I guess DeFi Ranger is something from their own research. So I highly appreciate their research work, and I will highly recommend just going to them and head over and learn more about the tools and what more we can do with it, right? Now let's talk about the challenges, right? The challenges are still there. First is to reduce this time delay, right? The time delay of analysis, right? We are doing the time delays in the same timeline, the same time frame of this pending block, right? We don't have enough time. If our tool or if our approach is not efficient, it might happen that we are still running our analysis and the hack will went through, right? So we had to reduce our analysis time as slow as possible, right? So that is one thing we want and we need. The second thing is the flashwords, right? So you might have observed that all this analysis is kind of dependent upon the mempool, right? We are relying upon. We are working on the pending transactions that are coming into the mempool. We are analyzing them and just making our next steps of it. What if the transactions are not submitted under the mempool? What if some transactions are not there in the mempool, right? Then our analysis kind of not making sense, right? Because of these flashwords. So flashwords are a second important thing that we want to take care about. So these are two challenges that we are facing and we want to continue our research on. And anyone who want to contribute, feel free to ping us and join the team maybe, or research work. Like it's an open research, like anyone can contribute to it. Right. So I would say thank you. That's it. That's most of the research is going on currently. I'm planning to move ahead with it, do some more work on it, and probably find out some efficient approach and solutions. Right. That's it.